Let us now understand what is a functional group. So in organic compounds, there are certain special groups present in the compound which determine the chemical characteristics of that compound, which determine the chemical characteristics or chemical properties of that compound. So these atoms or the groups of atoms which determine the chemical properties of organic compounds, they are known as the functional groups, right? Now, if we start with alkanes, which are the simplest organic compounds, that is the simplest, we can say hydrocarbons. Okay, these are the compounds which have only hydrogen and carbon in them. So simplest in them is the alkanes. Now, in case of alkanes, there is no special group present. There is no special groups present. So alkanes are the exceptional cases. Alkanes are the exception. There is no special group present here, but still they have their characteristic chemical properties. Now, for example, you can take methane. There is ethane. Any of the compounds which contain only carbon and hydrogen and only single bonds. There should be only single bonds. There cannot be any multiple bond. Now, then we move to alkenes. In case of alkenes, the special characteristic of the molecule will be the carbon-carbon double bond. So this will be considered as the functional group. Carbon-carbon double bond will be considered as the functional group because it will be responsible for the characteristic properties or the characteristic chemical properties of alkene molecules, right? Then we move to alkynes. In case of alkynes, there is carbon-carbon triple bond. Now this carbon-carbon triple bond is going to be responsible for the chemical characteristics of the molecules. So this is the functional group in case of alkynes. Now then next is arenes. Arenes are the aromatic compounds, that is the compounds having benzene ring. So here we will be having alternate single and double bonds. Alternate single and double bonds. So this alternate single and double bond will be considered as the functional group because it is going to determine the chemical properties of arenes. Okay, the next functional groups can be like we have alkyl halides. Alkyl halides. In this, the functional group is the halogen atom, which is attached to the carbon chain. So if we say it is CH3, CH2X. Now we said that alkyl halides, they show nucleophilic substitution reactions. It is because of this bond only. So it is determining the chemical properties of alkyl halide molecule. Then we have alcohols. In case of alcohols, the functional group is OH. In case of amines, the functional group is NH2. Then ethers are there. Here we can have this kind of structure. On two sides of oxygen, there are alkyl groups. So this is the functional group. The functional group in case of ethers is this one. Here it is X. Here it is OH. Here it is NH2. Likewise, we can have thiols. Thiols. Now, alcohols are the compounds having OH as the functional group. Now, in place of oxygen, if there is sulfur, so if I write CH3, CH2, SH, not OH, but SH. Now, this is thiol. Now, here the functional group is SH. Right? So, next you can have any number of examples, like we can have nitro compounds in which the functional group is going to be NO2. So in case of nitro compounds, the functional group is going to be NO2. Now R is the general, if we need to write alkyl group, R will be the alkyl group. Okay, so generally if we are writing alkyl groups, we use capital R there. Okay, so then we will be discussing the functional groups having carbon-oxygen double bond or carbon-nitrogen triple bond. Functional groups having carbon-oxygen double bond or carbon-nitrogen triple bond. So here number one is aldehydes. So here will be carbon-oxygen double bond carbon nitrogen triple bond. Okay, so aldehydes are C double bond O H. Here the functional group is this one, CHO group. Okay, then we have ketones. We have R. On two sides of carbon oxygen double bond, there are two alkyl groups. So this is the functional group. Now, because of this group, ketones will be having their specific chemical properties. Then next compound in which there is carbon oxygen double bond, there are carboxylic acids. Acid means here carboxylic acids. Carboxylic acids. So it is R, C double bond O, OH. Now the functional group here is so sorry. Okay. Then fourth one is esters. R, C double bond O, OR. So here it is C double bond O, OR. Now this is the functional group here. Because of this, it will be having the specific chemical properties. Now let us just clear the screen. And we can now move to the next groups. There can be acid halides. You can put the next number. I think it was 5th. Acid halides. So in case of acid halides, this is the structure. So the functional group is, okay, then acid amides can be there. R, C double bond O, NH2. Right? Then there can be anhydrides. Acid anhydrides are C double bond O, O, then again C double bond O, R. These are anhydrides. Okay. Then next, nitriles. Nitriles are the compounds which have CN group, cyano group. So R, C triple bond N. Okay, so any group which imparts specific characteristic chemical properties to an organic compound, it is known as the functional group. Now, in case of alkanes, there is no functional group, but still they have the characteristic chemical properties. In alkenes and alkynes, multiple bond is the functional group. Right? Now, let us just clear the screen. And now we will be understanding what is a homologous series. Homologous series. Okay. Homologous series is the similar compounds having same functional group, and similar chemical characteristics. Same functional group and similar chemical characteristics. Okay, so this is the definition of a homologous series. Now, what are the characteristics of homologous series? Characteristics of homologous series. Number one characteristic is they will be having same functional group. Same functional group. For example, if we consider alcohols, any alcohol you take, it will be having OH group. Okay, any alcohol you take, it will be having OH group. So now this will be known as the member of homologous series. Okay, now the second characteristic is the subsequent members, they differ by one CH2 group. subsequent members differ by one CH2 group. For example, if I say CH3CH2OH is the alcohol I have, right? And the next member is, so this is ethanol, this is propanol. Now, how they are differing from each other? They are differing with one CH2 in between, right? So the difference in their molecular mass will be, what is the molecular mass of this CH2 group? What is the mass of this CH2 group? 12 for carbon and 2 for hydrogen. So it will be 14. So they will be differing from each other by a mass of 14, right? Then next is they will be having same general formula. Same general formula. Again, I'm taking the example of an alcohol. So the general formula for alcohol is CnH2n plus 1 OH. CnH2n plus 1 OH. The N can be 1, 2, 3, and so on. Okay. Now, if we apply this formula to these two molecules, here Cn, N is 2 because 2 carbons are there. H, 2 into 2 plus 1 OH. Okay. Now, how many hydrogens are there? 3 plus 2, 5. So here you see it is 4 plus 1, 5. OH, OH. Right? Same formula is applicable to this molecule also. So here N will be 3, C3, H2 into 3 plus 1, OH, C3, H7, OH. 1, 2, 3, C3, 3 plus 2, 5 plus 2, 7, H7, OH. Okay. Okay, then the last property of the homologous series will be, they will be having similar chemical properties and there will be a proper gradation of physical properties with the increase in molecular mass. Similar chemical properties and proper gradation in physical properties with increase in molecular mass. With increase in molecular mass. So if you see, so chemical properties we know because they are having the same functional group, so they will be showing the similar chemical properties only, right? Then gradation in the physical properties. CH3OH, CH3CH2OH, CH3CH2CH2OH. Now here the molecular mass is increasing. So with the increase in molecular mass, there will be change in the melting points. Methanol is going to have some different melting point. Ethanol will have different melting point. Propanol will have different melting point, but there will be a regular trend. If it is increasing with the increase in molecular mass, there will be a regular trend that moving from this to this, it is regularly increasing. Okay, so this is what is the meaning of homologous series. You do not need to cram it. You just need to understand what is the meaning of a homologous series. And next we will be discussing the next topic. Hopefully it will be the nomenclature of the organic compounds.